In our previous lesson, we saw what prefix and postfix expressions are, but we did not discuss how we can evaluate these expressions. In this lesson, we will see how we can evaluate prefix and postfix expressions. Algorithms to evaluate prefix and postfix expressions are similar, but I'm going to talk about postfix evaluation first because it's easier to understand and implement. And then I'll talk about evaluation of prefix. Okay, so let's get started. I have written an expression in infix form here, and I first want to convert this to postfix form. As we know, in infix form, operator is written in between operands, and we want to convert to postfix, in which operator is written after operands. We have already seen how we can do this in our previous lesson. We need to go step by step, just the way we would go in evaluation of infix. We need to go in order of precedence, and in each step we need to identify operands of an operator, and we need to bring the operator in front of the operands. What we can actually do is we can first resolve operator precedence and put parentheses at appropriate places. In this expression, we'll first do this multiplication, this first multiplication, then we'll do this second multiplication, then we will perform this addition, and finally the subtraction. Okay, now we will go one operator at a time. Operands for this multiplication operator are a and b, so this a asterisk b will become ab asterisk. Now next we'll need to look at this multiplication. This will transform to cd asterisk, and now we can do the change for this addition. The two operands are these two expressions in postfix, so I'm placing the plus operator after these two expressions. Finally, for this last operator, the operands are this complex expression and this variable e. So this is how we will look like after the transformation. Finally, when we are done with all the operators, we can get rid of all the parentheses. They are not needed in postfix expression. This is how you can do the conversion manually. We will discuss efficient ways of doing this programmatically in later lessons. We will discuss algorithms to convert infix to prefix or postfix in later lessons. In this lesson, we are only going to look at algorithms to evaluate prefix and postfix expressions. Okay, so we have this postfix expression here, and we want to evaluate this expression. Let's say for these values of variables a, b, c, d, and e. So we have this expression in terms of values to evaluate. I'll first quickly tell you how you can evaluate a postfix expression manually. What you need to do is you need to scan the expression from left to right and find the first occurrence of an operator. Like here, multiplication is the first operator. In postfix expression, operands of an operator will always lie to its left. For the first operator, the preceding two entities will always be operands. You need to look for the first occurrence of this pattern, operand, operand, operator, in the expression. And now you can apply the operator on these two operands and reduce the expression. So this is what I'm getting after evaluating 2, 3 asterisk. Now we need to repeat this process till we are done with all the operators. Once again, we need to scan the expression from left to right and look for the first operator. If the expression is correct, it will be preceded by two values. So basically we need to look for first occurrence of this pattern, operand, operand, operator. So now we can reduce this. We have 6. And then we have 5 into 4, 20. We are using space as delimiter here. There should be some space in between two operands. Okay, so this is what I have now. Once again, I'll look for the first occurrence of operand, operand, and operator. We will go on like this till we are done with all the operators. When I'm saying we need to look for first occurrence of this pattern, operand, operand, and operator, what I mean by operand here is a value and not a complex expression itself. The first operator will always be preceded by two values, and if you will give this some thought, you will be able to understand why. If you can see, in this expression we are applying the operators in the same order in which we have them while parsing from left to right. So first we are applying this leftmost multiplication on 2 and 3, then we are applying the next multiplication on 5 and 4, then we are performing the addition, and then finally we are performing the subtraction. And whenever we are performing an operation, we are picking the last two operands preceding the operator in the expression. So if we have to do this programmatically, if we have to evaluate a postfix expression given to us in a string, like this, and let's say operands and operators are separated by space, we can have some other delimiter like comma also to separate operands and operator. Now what we can do is we can parse the string from left to right. In each step in this parsing, in each step in this scanning process, we can get a token that will either be an operator or an operand. What we can do is, as we parse from left to right, we can keep track of all the operands seen so far, and I'll come back to how it will help us. So I'm keeping all the operands seen so far in a list. The first entity that we have here is 2, which is an operand, so it will go to the list. Next we have 3, which once again is operand, so it will go into the list. Next we have this multiplication operator. Now this multiplication should be applied to last 2 operands preceding it, last 2 operands to the left of it, because we already have the elements stored in this list. All we need to do is we need to pick the last 2 from this list and perform the operation. It should be 2 into 3, and with this multiplication we have reduced the expression. This 2 3 asterisk has now become 6. It has become an operand that can be used by an operator later. We are at this stage right now that I'm showing in the right. I'll continue the scanning. Next we have an operand. We'll push this number 5 onto the list. Next we have 4, which once again will come to the list. And now we have the multiplication operator, and it should be applied to the last 2 operands in the reduced expression. And we should put the result back into the list. This is the stage where we are right now. So this list actually is storing all the operands in the reduced expression preceding the position at which we are during parsing. Now for this addition, we should take out the last 2 elements from the list, and then we should put the result back. Next we have an operand. We are at this stage right now. Next we have an operator, this subtraction. We will perform this subtraction and put the result back. Finally, when I'm done scanning the whole expression, I'll have only one element left in the list, and this will be my final answer. This will be my final result. This is an efficient algorithm. We are doing only one pass on the string representing the expression, and we have our result. The list that we are using here, if you could notice, is being used in a special way. We are inserting operands one at a time from one side, and then to perform an operation, we are taking out operand from the same side. Whatever is coming in last is getting out first. This whole thing that we are doing here with the list can be done efficiently with a stack, which is nothing but a special kind of list in which elements are inserted and removed from the same side, in which whatever gets in last comes out first. It's called a last in first out structure. Let's do this evaluation again. I have drawn logical representation of stack here, and this time I'm going to use this stack. I'll also write pseudocode for this algorithm. I'm going to write a function named evaluate postfix that will take a string as argument. Let's name this string expression, exp for expression. In my function here, I'll first create a stack. Now for the sake of simplicity, let's assume that each operand or operator in the expression will be of only one character. So to get a token or operator, we can simply run a loop from 0 till length of expression minus 1. So expression I will be my operand or operator. If expression I is operand, I should push it onto the stack. Else, if expression I is operator, we should do 2 pop operations in the stack, store the value of the operands in some variable. I'm using variables named op1 and op2. Let's say this pop function will remove an element from top of stack S and also return this element. Once we have the 2 operands, we can perform the operation. I'm using this variable to store the output. Let's say this function will perform the operation. Now the result should be pushed back onto the stack. If I have to run through this expression with whatever code I have right now, then first entity is 2, which is operand, so it should be pushed onto the stack. Next we have 3. Once again this will go to the stack. Next we have this multiplication operator. So we will come to this else if part of the code. I'll make first pop and I'll store 3 in this variable op1. Well, actually this is the second operand, so I should say this one is OP2 and next one will be OP1. Once I have popped these two elements, I can perform the operation. As you can see, I'm doing the same stuff that I was doing with the list. The only thing is that I'm showing things vertically. Stack is being shown as a vertical list. I'm inserting or taking out from the top. Now I'll push the result back onto the stack. Now we will move to the next entity, which is operand. It will go onto the stack. Next 4 will also go onto the stack. And now we have this multiplication. So we will perform 2 pop operations. After this operation is performed, result will be pushed back. Next we have addition. So we will go on like this. We have 26 pushed onto the stack now. Now it's 9 which will go in. And finally we have this subtraction. 26 minus 9. 17 will be pushed onto the stack. At this stage we will be done with the loop. We are done with all the tokens, all the operands and operators. The top of stack can be returned as final result. At this stage we will have only one element in the stack, and this element will be my final result. You will have to take care of some parsing logic in actual implementation. Operand can be a number of multiple digits, and then we will have delimiter like space or comma, so you will have to take care of that. Parsing operand or operator will be some task. If you want to see my implementation, you can check the description of this video for a link. Okay, so this was postfix evaluation. Let's now quickly see how we can do prefix evaluation. Once again, I've written this expression in infix form, and I'll first convert it to prefix. We will go in order of precedence. I first put this parenthesis. This 2 asterisk 3 will become asterisk 2 3. This 5 into 4 will become asterisk 5 4. And now we will pick this plus operator, whose operands are these two prefix expressions. Finally, for the subtraction operator, this is the first operand and this is the second operand. In the last step, we can get rid of all the parentheses. So this is what I have finally. Let's now see how we can evaluate a prefix expression like this. We will do it just like postfix. This time all we need to do is we need to scan from right. So we will go from right to left. Once again we will use a stack. If it's an operand, we can push it onto the stack. So here for this example, 9 will go onto the stack. And now we will go to the next entity in the left. It's 4. Once again we have an operand. It will go onto the stack. Now we have 5. 5 will also be pushed onto the stack. And now we have this multiplication operator. At this stage we need to pop 2 elements from the stack. This time the first element popped will be the first operand. In postfix, the first element popped was the second operand. This time the second element popped will be the second operand. For this multiplication, first operand is 5 and second operand is 4. This order is really important. For multiplication, the order doesn't matter, but for say division or subtraction, this will matter. Result 20 will be pushed onto the stack, and we will keep moving left. Now we have 3 and 2. Both will go onto the stack, and now we have this multiplication operation. 3 and 2 will be popped and their product 6 will be pushed. Now we have this addition. The 2 elements at top are 20 and 6. They will be popped and their sum 26 will be pushed. Finally we have this subtraction. 26 and 9 will be popped out and 17 will be pushed. And finally this is my answer. Prefix evaluation can be performed in a couple of other ways also, but this is easiest and most straightforward. Okay, so this was prefix and postfix evaluation using stack. In coming lessons we will see efficient algorithms to convert infix to prefix or postfix. This is it for this lesson. Thanks for watching.